Hello everyone. Before starting the lesson, try the warm-up. Bob's height above the ground on a Ferris wheel is shown here. How high is the axle on the wheel? Here's the axle in the middle of the Ferris wheel. What is the diameter of the wheel? Diameter is the total distance across. How long does it take for one revolution? One revolution would be all the way around the Ferris wheel once. And how many times did Bob go around the wheel based off of what we see on the graph? Now, just for clarity, I'm going to add these lines to the drawing of the graph so that you can better see where they end up on the axis. But I'd like you to pause the video and see if you can answer these questions. The central axis on this graph is y equals 12. That corresponds to the middle. That's where the axis would be. That's the middle height. So, how high is the axle on the wheel? 12 meters. The diameter of the wheel, well, if I look at the amplitude of my function, it's 10. So from the central axis, or from the axle, I go up 10 meters to get to the maximum height, or down 10 meters to get to the minimum height. So the highest is 22 meters, the lowest point is 2 meters above the ground. So from one side to the other, that's a distance of 20 meters. So the diameter of this wheel is 20 meters. And how long does it take for one revolution? Well, one revolution is one cycle on the graph. So if we look at one cycle from the beginning to the end of it, before the pattern starts repeating again, that takes 60 seconds. From 0 to 60 seconds is 60 seconds for one revolution. And if we look at the graph, there are 2 complete cycles, so that means Bob went 2 times around the Ferris wheel. That was an example of a sinusoidal function, and in this lesson we're going to be interpreting graphs of sinusoidal functions. So we're going to relate sinusoidal functions to their graphs and what they mean. We're just going to be figuring out how to read the graphs and relate it back to the context of the question. Now, all of the examples I'm going to look at in this lesson relate back to the Ferris wheel idea, and we covered what that looks like in the warm-up. So here I have 2 different Ferris wheels, Ferris wheel A and Ferris wheel B. For both, we are graphing the height of a person on that Ferris wheel over the amount of time that they're on the ride. And we can see that these graphs look different, so that means there is a difference between these 2 Ferris wheels. So we're going to walk through some different questions. The first one I have for you is, what is the period? So I'd like you to pause the video and see if you can figure out what the period of each of these functions are. Well, remember, the period is the length of one cycle. So for both of these, I can figure out how long one cycle is by going from peak to peak. From 10 to 50, that's a span of 40 seconds. And it's the same for each one. So both these Ferris wheels have the same period. But what does that mean? What does the 40 seconds represent when we're talking about these Ferris wheels? Relate it back to the warm-up. What does the 40 seconds mean? Well, it means they both take 40 seconds to complete one revolution. So here's how we're relating the graph to the context of a Ferris wheel. The period would be how long it takes to go around the Ferris wheel one time. Now we're sticking with the same Ferris wheels. These are the same graphs as in the last example, but this time, what is the equation of the axis? And then, once you have the equation of the axis, explain with context. So talk about what that equation of the axis means when we're talking about each Ferris wheel. Well, we can see the central axis for the first Ferris wheel is y equals 7. And for the second one, y equals 4. But what does that mean? How do we use this to explain anything about the Ferris wheel? Well, if you recall from the warm-up, the central axis refers to where that axle is, the axle of the wheel. The center of the wheel is 7 meters above the ground for the Ferris wheel A and 4 meters above the ground for Ferris wheel B. So we've related part of the graph to what it means in the actual situation. So I'm still talking about the same Ferris wheels, but this time we're going to look at what the amplitude of each one is and what that means. So pause the video, see if you can find the amplitude of each of these and explain what it means in a description about the Ferris wheel. So we look at each graph, and from the central axis we go up to the maximum point. So for the first one, this is at 7. This looks to be at 13. So from 7 to 13, we're going up 6. So the amplitude is 6 meters for the first Ferris wheel and 3 meters for the second. But what does that mean? How can we use that to explain the context of the Ferris wheel? Well, this is just talking about the radius of the wheel. From the axle of the wheel to its highest point, it's 6 meters up. So that's the radius of the wheel. So the first Ferris wheel has a radius of 6 meters, and the second Ferris wheel has a radius of 3 meters. So again, we're relating what the amplitude means in relation to a Ferris wheel. Now, something perhaps a little more interesting is this example where we're going to find what is the speed of a person on the ride. Okay, so we've already done a lot of work. I'm just reminding you the radius of Ferris wheel A. Radius of Ferris wheel A is 6 meters. We're going to use that to calculate how fast somebody's moving on this ride. I'm going to show you how to calculate the speed of Ferris wheel A, and then I'm going to let you try to calculate the speed of Ferris wheel B. First things first, to calculate speed, we need to know the distance a person is traveling and how much time it takes to travel that distance. So if you think about riding a Ferris wheel, we're going around a circle. One rotation around the circle is the circumference of the circle. That's the total distance that they're traveling around the outside of the circle. So we need to know the circumference of the circle and the amount of time it takes to travel that circumference. So then we'll have the distance and the time. Now maybe you've forgotten how to calculate the circumference of a circle, but it's 2 pi r, 2 times pi times the radius. So if the radius of Ferris wheel A is 6 meters, then we do 2 times pi times 6. And if you do that in your calculator, you'll get approximately 37.7 meters. So one time around the Ferris wheel, a person is traveling 37.7 meters in the total distance around the outside. How long does it take to do that? Well, that goes back to the period. The period is 40 seconds. So to find the speed, we take the distance traveled divided by how long it took to do that. 37.7 meters divided by 40 seconds is approximately 0.9 meters per second. That's the speed that you're traveling on Ferris wheel A. Now I'd like you to pause the video and try to find the speed that you're traveling on Ferris wheel B. If you follow the same method as I outlined here, you'll find that the circumference of Ferris wheel B is about 18.8 meters. So you travel 18.8 meters in 40 seconds, that's the length of one cycle. 18.8 divided by 40 is approximately 0.47 meters per second. That's the speed on Ferris wheel B. So for this last example, I'd like you to put together all the things you've learned and see if you can come up with the speed of a person on this ride. This is a different Ferris wheel. We haven't talked about it yet, but you can see the graph of the motion on this Ferris wheel, and you have enough information here to figure out what the speed of a rider on this Ferris wheel would be. So pause the video and try to figure this out before you check back in. You can do a little bit of an analysis. The central axis is y equals 8. The highest value is 15. The lowest value is 1. That means the amplitude is 7. From 8 up to 15 is 7 units, or from 8 down to 1 would be 7 units. So either way, the amplitude is 7. That's the radius of this Ferris wheel. If you know the radius, you can calculate the circumference. So now I know the total distance around the Ferris wheel. Now I just need to know the time it takes to go once around the Ferris wheel. We need to find the period for that. So you can start here. One complete cycle would end here from 0 to 80 seconds. So the period is 80 seconds. Or you can measure from the maximum, 20, to the next maximum, which is 100. From 20 to 100, that's a span of 80 seconds. Or from the minimum to the next minimum, that's a span of 80 seconds, like I've shown here. Either way you do it, the period is 80 seconds. So we take our distance, divide by time, and we get the speed, about 0.55 meters per second for Ferris wheel C. So I showed you a little bit how you can relate a graph to explaining a situation that's being described. And now it's just time to practice that. So the practice questions are listed. They're here. They're on your unit outline. As you work, if you have any issues, please reach out for help.